Thank you so much for sending this question. This is an important type of factoring, and you might need a review of factoring to be able to do this one. It is a little tricky, and it uses what's called the factor by grouping method. Here's what we're going to do. We're going to try and find a way to break this negative 10x into two groups of x's. I don't know how you've done that before. I've always done it with this little number chart. And in the top, I'm looking for a number to multiply to. And I'm going to do 3 times 7. That's the coefficient of x squared. And the constant at the end is 21. And then the number in the middle, the coefficient of x, is negative 10. So what this number chart is leading me to do, it's just a puzzle. It's like a find the numbers. It's telling me find two numbers that when I multiply, I get 21. And when I add, I get negative 10. So two numbers that multiply to 21 and add to negative 10. You might think 3 and 7, and that's right. We just need to make them both negative because a negative 3 times negative 7 is positive 21. Negative 3 plus negative 7 is negative 10. So those are in fact the right number. So here's what I do with those numbers. We have our 3x squared, but this negative 10x, I'm going to break it up as a negative 3x minus 7x plus 7. Now I have 4 terms and I'm ready to do factor by grouping. To do factor by grouping, I'm going to think of this 3x squared minus 3x as one group, and I'm going to look for the greatest common factor, which you may already recognize is 3x. And I'm going to factor out a 3x. So 3x squared divided by 3x, when I do that division, 3 goes into 3, and then x squared divided by x gives me x. So what you might be thinking of is off to the side, what is 3x squared divided by 3x? And the answer is x. So that green x is what goes inside the parenthesis. And then I do the same thing to the negative 3x. What is negative 3x divided by this common factor 3x? And the answer is negative 1. Now I'm going to group the negative 7x and the 7 and do the same thing. You might notice that the common factor is going to be either, you might see it as a 7 or a negative 7. I'm going to use a negative 7. I'll show you why in just a minute, because that might be what went wrong when you did this. But when I take the negative 7 out, negative 7x divided by negative 7 is going to give us x. Seven divided by negative 7 is negative 1. What I'm going for here is to get a common factor after I do the grouping. So this x minus 1 matches up. Because the x minus 1 matches up, I can finish this problem by taking the x minus 1 and then the 3x and minus 7. Do you see where each of those came from? The pink 3x and the blue minus 7. And that's it. I can check this with FOIL. First times first is 3x squared. Outside times outside, negative 7x. Inside times inside, negative 3x. Last times last, positive 7. Combine these two to simplify, and I get 3x squared minus 10x plus 7 which if we look at the top, that's what we started with. So my FOILing, my multiplication has shown that that is in fact correct. Let me show you an error that you might make. And let me try to erase some of this without erasing the whole thing. And I'm going to fit it in off to the side here. So watch what you might have sometimes done. When we get to this step, 3x squared minus 3x minus 7x, and you group this 3x squared minus 3x. If you factor out, well, this one, we factor out the 3x, and we'd get the 3x, x minus 1. But then when we go on to the negative 7x plus 7, if you factored out a positive 7, do you see what's going to happen there? When we factor out a positive 7, so negative 7x divided by positive 7 would be negative x, and 7 divided by 7 would be plus 1. And that doesn't give us something common to work with. So when that happens, if you don't get the same term, you want to look and see, well, what could I do differently? It's not that this was wrong. It's just that it didn't give us the result we wanted. Sometimes with factoring, it's trial by error, and you have to try a few things before it works. But the key is that we're trying to get these like terms. Now, a number of students, when you're doing this factor by grouping, it seems that students will get to this first step and even to this next step, but this last step of pulling out that final x minus 1 is where the error seems to take place the most often, where students just stop the problem and don't complete it. So make sure you complete it all the way through. This isn't the question you asked about, but it's a similar one. So I thought I'd take advantage of your attention since you're watching this video. If you want to stop now, you could stop the video, but if you want to see one more, just to be certain you've got this, then watch with me with this one more similar example. I'm going to start by looking for that number chart, like that puzzle, to figure out what way I can break this negative 13x. The way I do that is I multiply the 4 and the 9, gives me 36, and then I just pull the number out of the coefficient, which is just the 9. And oh, I'm sorry, not the 9. We use the 9. We use the 4 times 9 to get the 36. We pull out the negative 13, the coefficient of the x term right here, right? So that's the first step. We've set up our number chart, our puzzle, so that we're looking for two numbers that multiply to give us 36, and they add to give us negative 13. Well, this one is right here for us. It's the 4 and the 9. So that worked out nicely, because when I add 4 plus 9, I get 13. But do you see that that doesn't give me the negative 13? What I need to get the negative 13 is I simply make both of these negative, because I can check this now and say negative 4 times negative 9 equals positive 36, so the top number is correct. And then negative 4 plus negative 9 gives me that green negative 13, so this bottom number is correct. So I've found and then checked to verify that the negative 4 and the negative 9 are in fact the right way to break this negative 13x up. So I'll take the 4x squared and keep it, but then I'm going to break the negative 13 into a negative 4x and a minus 9x. and then I'm going to keep the plus 9. Do you remember the next step? The next step is to group these together, and I can group the 4x and the negative 4x, or I'm sorry, 4x squared and the negative 4x, and then I can group the negative 9x and the 9. Let me show you that if you had reversed this negative 4 and negative 9, that would have been okay also. We would have gotten the same result. And in fact, let me show you, we'll do this problem a second way. Over here, I'll show you what would have happened if we had in fact listed the numbers that way. So if we had put the 9x first, I want to show you that it still would have all been okay. So if I swapped the order there of the negative 4x and the negative 9x, I want to show that we could have still done this process. It doesn't rely on guessing that correctly. When I take the 4x squared minus 4x, I'm looking for a greatest common factor. I'm going to take a 4x. Off to the side, what I'm thinking is, here's the 4x squared. If I divide that by 4x, I'm left with x. 4x squared divided by 4x gives me x. And then I'll take this negative 4x. Let me keep it consistent with the color so that you can see where everything's coming from. This negative 4x, if I divide that negative 4x divided by 4x, I get a negative 1. So we have an x and then a minus 1. Next, I move on to the second grouping, negative 9x plus 9. You might see the GCF as 9, or you might see the common factor as negative 9. And you have to pick one or the other. We'll try it and see which one is right. Let me show you what happens if I choose incorrectly, which you wouldn't know you were choosing incorrectly. But let me show you what happens if we choose incorrectly and select a positive 9. I'm saying that negative 9x divided by 9 is negative x. And then positive 9 divided by 9 is positive 1. And I recognize, oh, there's a problem. This x minus 1 doesn't match up to the opposite of x plus 1. You might notice that those are opposites. What I mean by that is x minus 1 is the opposite of 1 minus x. Which is the same as the opposite of x plus 1. So you might recognize that, but it's okay if you don't, because when I get here, I can just put a line through it and say, oh, that didn't work. Let me start over. I wouldn't actually erase this. I would just put a line through it. I can erase easily because this is like a whiteboard, but there's not a need to do the erasing. So let's try it again. We factor out our 4x and our x minus 1. That was good. But I recognize that what I needed was for these to be opposites. So instead of using a positive 9, I'm going to see what happens when I do a negative 9. And sure enough, I get the x minus 1. Let me show you why, just in case you're not sure. I'm up here with this negative 9x, and then with the 9, and I'm dividing those by our negative 9. Negative 9x divided by negative 9 is just the 1x. And that's where I have this x. 9 divided by a negative 9 is negative 1. That's where I get each of those. And now we've got something that'll work for us because we've got our common x minus 1. So let's pull that x minus 1 out. And what do we have left? We've got the 4x minus 9 left. Let me show you what I did there, with just in case. It's hard when you're just watching a video. I can't see where your mistake might be. But let me show you what I'm doing to get that result. I'm factoring out, when I pull this orange x minus 1, I'm pulling it out of each of these two terms, and what am I left with? 4x minus 9. So you could physically cross it out, just draw one line through it. I wouldn't put an x. I would ordinarily put a slash through it so you can still see it when you look back. But that's all there is to it. And the final answer is x minus 1 times 4x minus 9. You can check that with FOIL. The first times first, outside times outside, insides, and lasts. And it does in fact check out. Well, I hope this short video on factoring has helped you a little bit. And thanks again to the student who sent me the question.